how's it going, Algebra 1? It is Mr. Knight continuing on with a new, fresh set of notes that no one is probably excited for, but it is a necessary evil. We're going to have to get some practice with this stuff and know what we're talking about, okay? So, this is level 4, zeros of functions. I'd like you guys to recall from yesterday and maybe talk to a partner. What does zero of a function mean? Let's see if you guys can remember. And go. Alright, we're back. The zero of a function, all it is we call it the x-intercept, but more specifically, it's where our graph crosses the x-axis, right? It's just whatever that x-coordinate is that's on the x-axis. So, if we look at our line, the x-intercept, or the zero, is located right here. And we need to figure out what the x-coordinate of that guy is. Well, if I go over -1, -2, -3, then our zero of the graph is just -3. And that is it. But we can have more than one zero. It says find the zeros of each function, right? So just because this one we're dealing with a line, it's only going to cross the x-axis once. You get something, we call this a quadratic or a parabola. It's crossing more than once. We got one right here. We got one right here. So what are those x-coordinates? Well, x-coordinate is 0 right here. I'm going to put a comma. And then the other one is -1, 2, 3, 4, -4. Okay? Now, I'm not going to put those in parentheses. I'm not going to do this. There is a reason why I don't do that. What does that look like? Well, that looks like an actual point on a graph, 0, -4, which would be down here. And that's not what we're talking about. That's a point. These are just the zeros of the graph, so we don't want to include that. We just want the x-coordinates. So really, if we actually wanted the points of these guys, technically, that would be 0, 0, and it'd be -4, 0. This guy over here would be -3, 0. All right. Let's do one more. Let's do number 4, because it's a circle, and we want to talk about that guy. It's a little different looking, a little different. We have a 0 right here. We have a 0 right here. That's where they're crossing on the x-axis. Again, what are those x-coordinates? Well, this one is 1, 2. And this one is -1, -2, 3, 4, -5. Okay? So those are my zeros of my graph. And again, if I wanted the points, so I have the x-coordinates, but if I want the points, I have to do 2, 0. And this would be -5, 0. Now, what are you guys noticing with the points of all these guys? What are you noticing? What is similar about all of them? Go ahead and take a minute to talk to your partners, talk to your group mates, and just determine what is the same and be ready to share out. Okay? And go. All right, we're back. If you look, all the y-coordinates are 0. And in fact, that's true. The y-coordinate's always going to be 0 when we're finding the zeros of each function, which is kind of odd, right? That's why we call it the zeros. All we are doing is really, if we're looking where it crosses the x-axis, the y-coordinate is always going to be 0. Okay? Maybe we write that to the side. Y-coordinate is always 0. Okay? So let's try some on our own. I would like you guys to try. I want you guys to try number 5, and I want you to try number 6. Again, we're going to have multiple parts. These are different graphs. We're going to have multiple parts where they cross the x-axis. So determine what those zeros are. Go. All right, you're back. We look at number 5. It's crossing right here. The x-coordinate of that is -1, 2, 3, 4. It's -4. And again, if I wanted the point, that would be -4, 0. Number 6, this one's kind of a doozy, but same idea. we have the graph crossing here, here, and here. So we're going to have 3 zeros, so 3 x-intercepts. All right, so we have -1, -2, -3. We have -1, and we have 2. There we go. And again, I wanted the points be -3, 0, -1, 0, and 2, 0. Is this a function? Is this a function? Does this represent a function? Like, do these guys represent functions? Even though the 0 is repeating, I want you to talk to a partner and discuss that. And go. All right. These are still functions. Remember, just the x's can't repeat. Okay? The y's, they can repeat all day. They're totally fine. This guy over here, though, this guy technically would not be a function because it doesn't pass that vertical line test if we were determining if it was a function or not. Okay? It says find the zeros of each function. This guy is not a function. Okay? All right. Now you can actually do it algebraically too. Remember what I said. Your y-coordinate is always going to be 0. Always going to be 0. I know we're using f of x though, but remember you could treat this like y equals x plus 2. You can treat this one like y equals -2x plus 6. You are allowed to do that. So we're going to just think in that mindset for right now. If we want to find the 0 of each function, this is what we have to do. Since the y-coordinate is always 0, I have to first set my y equal to 0. Okay? I set my y equal to 0. My y is now 0. I'll do the same thing here. Okay? Now, the only thing I need to do now is actually solve for x. So I actually have to figure out what x needs to be to make this true. Well, this is kind of weird. This is really weird. We haven't really done much of this before, but it's using our algebra moves from Unit 2. Same idea. Look, I got to get the x by itself to solve. Okay? So what I got to do is I got to get rid of this 2. I got to get it to the other side, or undo it here. So I do the opposite. I subtract 2. 0 minus 2 is -2, and that equals x. So the 0 of my function is -2. And that's it. That's how you algebraically solve it. So the steps there is first, what I would do is change f of x to y. The second thing I would do is actually make y 0. Make y equal to 0. And then solve for x. Okay? If we repeat those steps, we're going to be golden. Okay? Let's do it for number 3. Again, I got to get x by itself. Again, the easy thing to do first, we have a 2-step equation, is get rid of what we're adding or subtracting. So let's subtract 6 to both sides. So we get -6 equals -2x. And the -2 is being multiplied, so I got to do the opposite. I got to divide both sides by -2. -6 divided by -2, that is a positive 3. So 3 equals x, and there it is. 3 is the 0 of this graph. And in fact, let's do something a little interesting. -2x plus 6, let's put that into Desmos, which is a graphing calculator. So if I put this, -2x plus 6, I'm going to get a line out of that. Okay? And remember, I said that 3 is the 0 of the graph. That is where it crosses the x-axis, right? So that is the x-coordinate where it crosses the x-axis. Well, the x-axis is here, and look at that. It's 3. 3 is the x-coordinate where it crosses the x-axis, and we solve that algebraically. So this function right here, which we saw on Monday, we can use to graph. We can use to graph lines. And now you're seeing that there's a connection between the physical world and kind of our math world. They're kind of coming together. there's a more visual aspect to math that we can discover using coordinates, okay? Kind of cool. What I'd like you guys to try to do now is I'd like you guys to try to find the zeros of 9, and likewise, I'd like you to do the same thing for number 12. And let's see what we come up with. Go for it. All right, we're back. Again, we got to treat this like y equals 1/3 x. And what do I do with my y? It's always 0. So now what I'm going to do is I'm going to add 6 to both sides. So 6 equals 1/3 x. How do I get rid of this 1/3 if it's next to it? They're being multiplied. I got to multiply both sides by the reciprocal. So I'll put that 6 over 1. So the 1/3, 3 over 1 cancel on that side. I'm left with x. On this side, I get 18 over 1, which is just 18. That's our 0. What about this guy? We have f of x equals 4x. So what we're going to do is we're going to do 0 for my y, which equals 4x. And this one's not too bad. You could go ahead and divide both sides by 4, or you just know that x has to be 0 to make this true. Right. So that's the zeros of functions. We're going to get more practice with this. And good luck on your homework assignment.